So we are going to start with the paired t-test and Wilcoxon sign rank test. So I hope you must have found this one a bit easy. And the difference you will see, especially in paired t-test also, that in paired t-test in SPSS, those of you who have performed paired t-test in SPSS, we'll see there we used to create a new variable for the difference of these paired value. But here in JAMO, it automatically calculates that difference and it plots the normality plot of that difference only. So again, we learn this session under the heading of basic concepts. Then it's a research question. What are the underlying assumptions, the commands, interpretation, and summary? So now I'll first explain what a paired value is. So if suppose, for example, if I want to measure a continuous variable on the same individual, like maybe systolic blood pressure, and I have measured the systolic blood pressure of those people in summer and then again in winter. So I am measuring this value twice at two different points. There can be a scenario when maybe under two different conditions. So I have measured blood pressure of one individual before workout and then probably after workout. Or in the single individual, if I'm doing this measurement over two different sites, like right arm and left arm. Or if I'm using two different machines, like maybe automatic BP machine and manual BP machine. So all these are example of paired values. Paired value of a single variable. It can be like at two different time point, which we have seen here. It can be under two different conditions, like in this example, before and after workout. It can be in the two different site, that is the right and left arm, or it can be using two different instruments like automatic blood pressure machine and the manual blood pressure machine. So all these values are known as the paired values, and paired t-test is applied for such case. So study design, so one type of study design could be like the participants are either the same individual tested at two different time points, or the participants are tested under two different conditions, but for the same dependent variable. As for example, this we have started with the set of five individual, and I have calculated the mean intake of calorie of these people. Again, this mean intake of calorie is a continuous variable. It's not a categorical one. So I have calculated their mean intake. Then I have done some dietary modification program, and after 6 weeks, again I measured their median intake of the calorie. So this is again median. It can be mean or median. Depending on that, you can take the sample, like maybe it is going to be a paired sample if you are going to compare the mean. Similarly, if you are like testing the participants for two interventions, like these are the 5 individual and you have compared the kilometer run on the treadmill for these 5 individual, and the same group, like after some time you are giving this intervention 2, which is the health drink 2, and then you are measuring the kilometer run on the treadmill. So you are measuring the same variable. Here the variable is same, but it is the two different intervention. So there is a health drink 1 and there is a health drink 2. So this is again a paired value. In this case also you can see that these 1 and 2, so 1 is a medicated, non-medicated lotion and 2 is a medicated lotion. So like if you have taken 4 kids and if I have applied over the right arm the medication 1 and left arm the medication 2, and in both the arm there is a dry skin and a red skin. So now if you compare outcome, you are comparing, that is the diameter of the redness. So that in both the cases, after like application of that ointment, you have measured the diameter of the redness and then you are comparing. So in this case also, you will apply this paired sample t-test. So these are the again same cases which we have seen in the first slide. So what could be the research question for such type of analysis? So I want to know whether any change is there in the scores in paired observation. So the first question could be, is there any mean difference in BMI value before and after a 6-week exercise program? What is the change in the main pain score measured on VAS before and after surgery? And probably, is there any difference in the marks obtained in pre-university and university examination of the MBBS student? So in all these cases, what have you observed? That there is a scale variable in each research question, and I want to compare it before and after. So the appropriate this type of study design, also known as the pre-post study, which we discussed before also, and the appropriate statistical test for such type of analysis is known as the paired sample t-test, also known as the paired t-test. So coming to the underlying assumptions, so the first assumption is that the one dependent variable, which is here, it is measured in the continuous scale. And here the categorical variable can be the two different time points. It can be the two different related group or the two intervention. And again, like independent sample t-test, there should not be significant number of outliers and it should be normally distributed. So the null hypothesis states that the population mean difference between the paired value is equal to 0, and alternate hypothesis states that the population mean difference between the paired value is not equal to 0. And its non-parametric counterpart is known as the Wilcoxon sign rank test. So if the assumptions of paired t-test is not met, like normality or there are too many outliers, then you should apply this Wilcoxon sign rank test. And in case of a paired sample t-test, remember here you will see that we will not talk about the homogeneity of variance, because here they are not two groups. It is the same group measured over two different time points or from the two different instrument or under the two different conditions. So that's why the homogeneity of variance concept is not applicable in this case. That's why you will not find a Welsh and a standard T like we used to see in the independent sample t-test. So many variable of interest that they are known to be not normally distributed. Like maybe there is a visual analog scale, which you will see that it is many a times it is not normally distributed. So when you already know that the variable of interest, or maybe from descriptive, because you have to perform descriptive analysis before you go for changing this significance testing or the inferential statistics. So you already know that from your descriptive statistics that the variable of interest is not normally distributed. So then you can plan beforehand to compare the median. So we will see how to do that in the GEMOV. So in GEMOV, I'll first show you the question. So the question which is there again, the first is I have to check the distribution of difference of the following parameters. Okay, let me see the chart. What is can you repeat regarding homogeneity? Arifun Hera. So homogeneity, I was telling that there is no sense if I say that whether the homogeneity variance assumption is met or not, because homogeneity of variance is applicable only when you have got two different sample. Then you say that they have withdrawn from the same population having the same variances. But in this case, you are measuring the same set of individual twice. So then the concept of homogeneity of variance is not applicable here. And then maybe I have to see whether there are any other question. So no, I think this is the last question. Any other thing which you want? Arifun Hera, did you get it? Like why there is no concept of homogeneity of variance for the paired sample t-test?
Yes, ma'am. Thank you.
Okay, thank you. So then I have to check the distribution of these variables like SpO2, CRP, bilirubin, urea, and creatinine. And then I have to see whether they are normally distributed or not. So I'll go to this. So this I was just doing some analysis to include that because now I have changed that template also. You said that there was some problem with that independent and dependent variable. So I have just filled up this template accordingly. So mean SpO2, if I have to compare, this is my GEMOV data sheet. I'll explain you the data first. So again, these are the same data set. You can see it is the name, gender, then their morbidity status like diabetes, smoking, hypertension, and just a sec. And then you can see, so they are measured, maybe there are few variables which have been measured twice, like this SBP, DBP, SpO2, temperature, cholesterol, 111 suggests that at the time of admission, and probably these 222, it's the at the time of discharge. So there are paired values for many variables and you can test. So like maybe for SpO2, the question is, I want to check whether there is any change in the SpO2 level at the time of admission and at the time of discharge. So I'll come to this analysis, and in analysis, if I use click this paired this test, then you will see there is a paired sample t-test. We have done this one sample t-test and an independent sample t-test. So if you click this paired sample t-test, this window will appear. Now you can shift your paired variable here. And since you see the size of the box is big, so you can shift multiple pairs here. So maybe like, but again, that has to be done pairwise. Like I have to do first with the SpO2. So first I'll show you with the one variable. So I have shifted SpO2 1, and then I have to shift its paired value. So paired value is SpO2 2. So I have shifted this SpO2 2. So this difference, it gives you the SpO2 minus SpO2 1 minus SpO2 2. So it checks like whatever difference has come, it will do the 1 and then minus this 2. So this is how this software understands this. And then again, I have to check first regarding the QQ plot. So I have clicked this QQ plot. So you will see that it automatically draft a plot for the SpO2 1 minus SpO2 2. Remember in SPSS, we used to create a new variable using the compute option. And then we used to do the variable 1 minus variable 2, that is the paired observation. And when that change used to come, then we used to get a plot. But in Gemo, once you click this QQ plot, it automatically gives you the QQ plot of this change. So here, if you'll see, this is not the, plotting is of the difference. You can see here, this plotting or the QQ plot normality checking is for the value of SpO2 1 minus SpO2 2. Now, I have seen that this is distributed along its diagonal line. So now I can go for the paired t-test, student t-test, and it's a non-parametric counterpart is the Wilcoxon rank. So now I will click this mean difference. So this mean difference will give you the there is a difference of 0.89, and minus means that the SpO2 decreased at the time of discharge. And if you click this 95% confidence interval, it will give you the 95% confidence interval of the difference. You can get an effect size. So effect size is minus 0.16. So this is not a very, effect size is low. And then you can see the descriptive. And then this descriptive will tell you the mean, median, and standard deviation and standard error of these two paired values. And again, that's it. So this is for the paired t-test. Now, if you want to write the paired t-test, how will you write? So I have just copied the same table from that Jamovi. And you can see here you will, in statistical result, you have to write the t value, its degree of freedom, and p value. And then you have to write the interpretation. So maybe one of you can read this interpretation. So maybe you can plot this box plot also of this SpO2. So probably because you have to comment on the box plot. So you can go to the exploration, descriptive, and in descriptive, you can like shift this SpO2. So you can shift this SpO2. You can shift this SpO2 also. And then you can see the box plot. So SpO2. And then if I go to the plot, you can see the box plot. And then you can see that there are no outlier in the SpO2. So now again, coming to the paired sample t-test. So again, I'll go to the result section. So one of you can read this. So have you seen the result? So let me again tell you. So there's one question. Can you tell what test is needed to do for the effect of exercise package for right and left arm and have pre-post of each arm? Okay. So you are having various combinations here. So like if you want to do the effect of exercise on right and left arm, you will perform one paired for right and left arm again, but that is the effect of exercise. Again, now the second is, can you इसको नीचे थोड़ा करना? Okay, let me, I'll see the question exactly. Yes. So first is the effect of exercise for the right and left arm. So I will see that what is the effect of exercise. So I will first do the blood pressure measurement in the right and left arm before the exercise. Then I will do it after the exercise. Then you can do pair t-test for the pre-post for the right and left arm also, and for the right arm before exercise and after exercise also. So there will be two paired t-test you can do. And again, if you are like measuring exercise with the 2 BP app, then again you can have multiple combination here. So if you are doing like right and left arm, but before and after, that you have to compare in the context of this paired value. But after this exercise therapy, because you are comparing it after the exercise therapy, so you can compare both right with right, left with left, and again right with left also. That can be done. But again, right and left will be done before and after. So there will be two combinations here. But all these cases, because all are these paired values, since you have mixed two paired values here. So you have mixed one paired value, which is the right and left arm, and you have mixed this pre and post exercise. Okay.
Ma'am, can I ask a question?
Yeah.
Ma'am, if there are two different interventions given to the right and left arm, for example, placebo for the right and intervention for the left arm, still the right and left becomes paired, ma'am.
No. Actually, no. We are confused. You are actually, ideally, we are not going to do. Then what will be your research question? Because we cannot do anything, like we cannot fit any combination. First, you need to think that what will be your research question if you are doing such type of study design where you are using because then your inter-observer, how will you comment there will be inter-observer this thing now, because if you are using the different instrument, if on the same individual you are using doing the BP measurement, but not the right and left arm, because right and left arm, again, you are creating another variable. So I don't think practically such combinations are possible where you are using one instrument for the right and the one instrument for left. So paired value, ideally, you should take only one paired value. In what situation you are going to plan any study like this?
No, in animal studies, with the rabbit, we take one side as placebo and other side as the drug. So at that time, it will come as unpaired or paired. That's like a very quick
No,
confusion.
see, these are the paired or the related values. So unpaired, though, it can never be, because unpaired will be always be the independent of observation. And if you are doing anything on the same individual, then it cannot be independent. It has to be a paired. For independent, remember the two values or the two columns, because how these values will come, it will be in a separate column. So for independence of observation, these separate columns should be unrelated. But in all the examples which you are citing, all the values will be related. It will not be, it can never be independent sample.
Yes, ma'am. Yes, ma'am. Understood. Thank you, ma'am.
Okay. So that's what I said. Even the twins, even the husband and wife, they are also not independent. So you should not, I said that if you are planning a study where you have to take equal number of men and women, then you cannot call 25 couples and take all wives in one group and all husband in one group. That will not be independence of observation. That will be again related samples. I hope I'm making myself clear.
Yes, ma'am. Yes, ma'am.
Okay, Teresi, thank you. So yes, can anyone read this result? Interpretation rather?
Yes, ma'am. The difference is
Difference in mean SpO2 level was normally distributed as found by the visual inspection of the QQ plot.
So
There were no
this I am talking about this graph, right? This one. This QQ plot is this visual inspection of this QQ plot. This is normally distributed.
there was no outliers in the visual inspection of the box plot, and there is significant increment.
Increment, not I will just delete because there is a significant, because SpO2 it has improved. The two significant has been typed, sorry. Yes, now you can do that.
There is significant increment in the SpO2 after the intervention, and the difference in the mean SpO2 was 0.089, which was 95% of the confidence interval.
I was typing, then only you people came from the breakout room, so this one value was left. So you can see like this from this table that it is 0.17, not even 17, minus 1.7 to 0.07. That confidence, this value. This you have to write. And significant is there because it is 0.03. Okay, but coherently, if you see, this is very small effect size. So that's how you have to write the this. But if you have to do like this was normal distributed. But let me take another one. Probably we can take, now this was for the one variable. Like if I am taking this LDH. And then simultaneously you have, okay, I took SGOT and then SGOT2. So each pair you have to enter together. Then probably I can go and take LDH. And then probably I can enter this LDH2. So you can enter multiple pairs here. But here if you'll see about this, the QQ plot, then you will see this SGOT QQ plot. This is not normally distributed. You can see this. It is like not across this diagonal line. And if you go down with this LDH, this is also not normally distributed. This you can see. So for these two, you need to perform the this Wilcoxon. So what I'll do, I'll shift these two variable back. And then I may click on the, instead of in student t-test, I'll click on the Wilcoxon rank, and then I will uncheck this because this Wilcoxon rank, it compares the mean rank. So you can see here the value of Wilcoxon. This is the descriptive. So it gives you the SGOT, the two values, that's mean value, and this gives you the Wilcoxon statistics and its p-value, and the effect size it calculates using the rank by serial correlation. So effect size is there, and both these are significant. The p-value, if you see the p-value is less than 0.001, and effect size is also moderate, the pre-post. Okay, and this, if you can see the mean, you have to write the descriptives also. So this is the mean SGOT at the time of admission, and this was at the time of discharge. Similarly, this was LDH at the time of admission, and this was at the time of discharge. So similarly, if you have found out that it is not normal, then you need to shift back the other normal one, and again you have to do that. Okay. So any question? Because it's 3:20, and today, because there is a PG activity in the department, so we have to finish it by 3:30. So in 10 minutes, I guess it is not possible for you people to practice the breakout room. So we may take few questions, or if you want me to repeat something, I may do that. Or there can be one possibility, like if you want to practice within yourself. Like maybe till after 3:30, we may go and you people keep on practicing, because in each group, there are few people who can act as a mentor by this time. So you people can do it between yourself, and then we may again check it tomorrow. What is the house?
Madam, I have a question.
Yes, Dr. Rabindra.
If I want to measure, say on 3 occasions, say for example, I am giving interventions on the health education on the 3 occasions. So I am measuring the score on 3 occasions. test can be applied in that case?
Okay, so in that case, we have actually, this is not covered in the basic, but I'll show you. There is option whenever you have got more than 2 groups, like we will discuss about this. When you have got 3 groups, like maybe you are talking 3 repeated. So if you
Yeah.
click ANOVA, there is a one-way ANOVA and there is a repeated measure ANOVA, this one. So if that is a parametric, then you can apply the repeated measure. And if it is a non-parametric, then again, this is the non-parametric counterpart. So if you see this is the parametric part. And if you see this is non-parametric. So this, for one-way ANOVA, this is the, if you have got more than 2 groups, for independent sample, like you have done 2 groups. So if there are more than 2 groups, this we will do tomorrow. But like the study design, which you have said, we will use this one. Repeated measure ANOVA.
Okay.
Yes.
Okay. Thank
So
you.
you can enter all these and then you can find a
This will
value.
not be covered in this session.
But you can practice that. Maybe I can demonstrate tomorrow. Maybe there is no breakout room, but I will demonstrate it. No problem.
Thank you.
Okay. Any other question, or should we go to the breakout room, or should we stop?
Ma'am, shall I ask one question, ma'am?
Yes, please, please. You're always welcome.
Ma'am, is there any reference stating that less than 50 is as small sample size?
Yes, yes. There are many standard books on SPSS, on Jamovi. We can share the Jamovi book that is there with us, the PDF. And the SPSS, that is a subscribed one. So that we cannot, but yes.
Okay, ma'am. Thank you.
To reference, you can quote the reference of LERD. There is a LERD statistics on SPSS, which is not in the form of access to the content. And then there is again, I said there is a book on Jamovi. That is also written by one person that they also suggest. And these 2 we have right now. But again, in the cross reference of that LERD also, you will see the person, there is a SPSS, this IBM, they have released a book also on SPSS, and it is written there also, this 50.
Okay, ma'am. So we can strongly say that the less than 50
Yes,
as
yes.
small sample size. Okay, thank you, ma'am.
You can write in the bracket LERD, LAERD.
Okay, ma'am. Thank you.
I mean, LERD statistics. If you type that in, you may get many reading material of LERD. And in LERD also, they have given the cross reference of this IBM statistics book. That book we don't have, but we have the subscription of LERD. So you can quote that.
Okay, thank you, ma'am.
Welcome. Any other chat box you can write? Your opinion, what do we do? Do you want to go to the breakout room, or should we conclude? No message. Saurabh, do you want to say something?
Yes, ma'am, we can practice in the individual groups. You
Yeah,
have divided us
I
into.
wanted that because I have moved to the rooms and I have seen there are many people who are very comfortable now with this. So at
Yes,
least
ma'am.
you people can demonstrate. So it will be a practice. So we will be done. So nice of you. Thank you. So we are opening the breakout room, and for 10 minutes we are here probably. Maybe by 10:40, like 1 or 2 can stay here in case you have any problem. Abhishek, Swati, Saket, can you stay? Abhishek, Swati and Saket? Okay. ये मुझे लगा कि ये कर देना चाहिए.